Welcome back to the channel STEM Friends. Tonight's video is a bit different as I would like to walk you through my HD hardware project. It will be especially interesting for those of us who have plants at home, as my project is all about a smart plant monitoring system. The system consists of an LCD, in my case it is the keypad shield one with the controller buttons, a soil moisture sensor, two LEDs with resistors and a buzzer. To bring all these elements together, I used the breadboard. Usually, this type of LCD is placed directly on top of Arduino, yet it leaves no free pins to connect the rest of the circuit to, unless you have the second Arduino board. So to free up some digital and analog pins, I connected the LCD with Arduino using male to female jumper wires. Having established the connection with digital pins 4 to 9, ground, 5 volt, reset and some other pins, I was left with digital pins 3, 10 to 13 and A5. Having connected the LCD, I added two LEDs on the breadboard, a red and a green one. Both were connected in a standard way, using the resistor and two jumper wires going to the positive wiring rail and the assigned digital pin. Then I added the most important component of the circuit that defines the behavior of all other features, the soil moisture sensor. As we need to use the analog pin to read its output, I connected the data pin to A5. The other two pins were connected to the positive and negative power rails. Lastly, the buzzer was also connected as the alarm-producing element for the critical state of the plant environment. Its negative end was connected to the GND, and its positive end was connected to the digital pin 3 that would be responsible for audible output. Moving on to the coding section of this project. I started with introducing the library for the LCD and assigning to it the digital pins 4 to 9, going by the conventional Arduino LCD connection establishment. For some different LCDs, the pins may vary, so these values were taken as example for the keypad shield LCDs and were proven to work for my circuit. Then the digital pins for the sensor, LEDs and the buzzer were assigned. I also added the moisture threshold for comparison. For testing of the code's functionality, I've set it to 500, yet for practical application the value would most likely be different. Each plant has different soil moisture recommendations that would mean a value estimated as super dry for one would be within the acceptable range of the other. Thus, it is important to know and test the normal moisture range of your plant. Coming back to the code. In the setup function, I initiated the working of the LCD screen of my size and set the cursor to the start of row 0. On the screen, I displayed the introductory message and returned the cursor back to the start of the line. I also added the serial begin line to allow readings output into the serial monitor. As for the loop function, I started with reading the sensor and writing it in both the serial monitor and at the LCD. Then I introduced two conditional blocks which define the behavior of LEDs and the buzzer. They also changed the soil status in both the LCD and serial monitor. As the focus of this task is to work with the Linux command line and bash scripting for hardware circuits, I then opened my Linux VM through Oracle VirtualBox. Once I logged into my VM, I started with the bash script in the new file read moisture. The point of my bash script was in storing a specific number of readings in a new file. I first told the system to run the file using the bash shell and declared the port variable to store the serial device that is connected to Arduino. Then I set a log file variable that defined the name of the file equal to the moisture log.txt. I used the echo command 3 times, which would show 3 different messages regarding the reading and recording processes that are going on in the Linux terminal. Then I read the port using the cat command with the reading limited to 15 seconds by the timeout. Once the readings were acquired, they were displayed and appended to the log file. Then I successfully managed to recognize the device through the USB port. I I also checked what port Arduino is connected to with the command grep_tty after checking the driver message. Then the command line experimenting began. I tried running the file after giving it the execution permission through adding X to its permissions list. It returned readings within 15 seconds from the start of the recording, as asked in the bash script. I also decided to install the screen communication tool through the terminal. Then I opened the screen in a new window with current readings being available. Thank you for following the journey of my project.